The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome back to another edition of our AMS webinar series for this month of May. Today, we're going to be doing something that we haven't done too much of. We're going to be starting out, when people start out with our product, especially the standalone Visual CAD/CAM product, they really don't know how to get started, especially if they are new to CAM. So we decided we'll do a webinar that's very for starting users of Visual CAD/CAM and also RhinoCAM. So we're going to be talking about machining 2D drawings in CAM. Starting with 2D drawings, how do we machine that in our CAM product? My name is Joe Anand. For those of you who haven't joined our webinars before, I'm the product manager here at MecSoft. I'll be joined today by Don LaCourse, our support manager, who's actually going to be showing the demo. Don, if you want to go to the next slide, please. So we want to keep this webinar as interactive as possible. With that in mind, please, you can use your chat window for any questions. You can type in your questions. I'll be in the background monitoring all questions, and we'll be able to answer that. If we need to stop Don during the demo, we can also do that. And as always, a recording of this webinar will be made available and sent to all the registrants. Actually, it'll be sent to all AMS users. So in case you're not able to attend, you will be able to watch it at your leisure. Regarding the agenda today, as I said, the title of our webinar is Machining 2D Drawings in CAM. We're going to be starting out with the geometry requirements for CAM in our products. We'll be talking about setup and stock considerations when using our product, and then talking about the machining operations of facing, pocketing, profiling, and drilling. And then a little bit about understanding cut levels in all of these machining operations, all of these milling operations, because that tends to trip up a lot of our starting customers. Then also machine simulation, material cut simulation, and then post-processing also. So without any further delay, Don, go ahead.
Okay. Hello, everyone. I hope everyone is doing well. If there's some reason you can't hear me good, just go ahead and type a question in there, and Joe will stop me. Maybe I need to make some adjustments. So I'm going to start right into the demonstration. I'm going to load. This is Visual CAD/CAM 2025. And I'm going, as Joe mentioned, the topic of the webinar is how do you program toolpaths if all you have is a 2D drawing? So let's go ahead and the drawing that we're talking about, let's go ahead and load it real quick. Okay, so what we have here is a 2D drawing. It lies on the XY plane, okay? And what I've done to prepare this drawing, I removed all the dimensions. You don't need, as long as you have the geometry, you don't need the dimensions. Now, one thing this drawing doesn't have is depth, okay, because it's only a 2D drawing. So you don't know what your depths are, ahead of time. You need to know what they are in your drawing, analyze your drawing, make sure you understand the thicknesses, the depths of each operation type, and what you need, how you need to cut it as far as Z depths. And to make that easier, let me just show you a little bit else of what I did. I'm going to unload the tool library real quick. So I basically just merged some of these curves just to make it easier to select, okay? Okay. So I did that ahead of time. And one other thing I did was down here on the regions tab, I created predefined regions for my holes, okay? So I got 3 sets of holes here. And that's just to accelerate the demonstration so we're not bogged down in doing the relatively simple stuff. If you want to know how to do the regions, predefined regions, we have videos and blog posts on how to do that, okay? So as I mentioned previously, what is critical for you to understand before you start doing CAM is the elevation of the part that you're wanting to machine, the different elevations. And your drawing may have an elevation view. Okay, if it does, that's great. That'll, that'll let you know how deep certain areas are that you need to cut. If your drawing doesn't have that, just take out the old-fashioned piece of paper and a pencil and draw a sketch, and just make sure you, write on there where the depths are and how deep they are, et cetera, et cetera. Okay, so to make that easy to understand here in the drawing, we're going to use a relatively new feature that we added. We're going to bring our elevation view directly into this drawing. So we're going to go to Modeling Aids, and it's the same thing, is very similar in Rhino. We'll go to Modeling Aids. We're going to go way down here to the background image section. We're going to pick Place, and it's going to open up a file browser, and we're going to pick this drawing right here. It's a PNG, or it can be a any type of drawing or pixel image format. Okay, so now it's asking me to pick some corners. So I'm just going to drag a window here. Okay, so it brought in this elevation view for this particular drawing. Now, you might think this is a relatively complex drawing. It is, to a point. And I do want to do a shout out to Sam Suka of Temporary Power by Design. This is an actual real world drawing. And I just wanted to thank them for allowing us to use it. And also, we have a case study and a blog post, okay, that goes over this exact drawing. It's going to be talking about all what we're going to do. So if you can go back later and just review this blog post, and there's also a case study you can look at. Okay, so let's look at this drawing right here. As you can see, it's kind of overlaid on my world origin. So I'm just going to use the move command, and I'm going to just drag it up a little bit more. Okay, so let's go ahead and turn that grid off for now. Okay. So now as we cam this drawing, we can look at this picture, and then we can see what we're actually doing in the this view, the front view of the part. And down here we have another view. We don't really need this. We could change that maybe to the right. No. We can do that from here. Let's go with the right side view just to make it different. Okay. Okay, so the first thing we're going to talk about next is the type of geometry that you can use for the different operation types. In our product, there's basically 5 different types of operations. There's hole making, there's 2-axis operations or 2.5-axis operations, 3-axis operations, 4-axis operations, and 5-axis operations. I'm going to go through the geometry requirements or options for each one. And we're going to start with hole making. We are going to be drilling and tapping some of these holes. So the minimum requirement to drill a hole is a point. Now we've got circles, okay, that illustrate our drilling operations. That's fine. You can use a circle. It'll calculate the center of the circle for your drill point. If you don't have circles, just create a point and you can use that, okay? For 2.5-axis operations, at minimum, you need a 2D drawing like we have, or just some curves that you have drawn on the screen. Those curves need to be on the XY plane, okay? It can be above the XY plane. It needs to be parallel to the XY plane. The CAD program will project them down to the XY plane when you actually create the operation. You can use a 3D model to do 2-axis operations. Any curve, any edge of a surface, or any basically edges and curves in a 3D model, when you pick those, it'll project those down to your XY plane, or where you're actually going to be drilling or cutting in what level, okay? So for 3-axis, you have to have a minimum of a surface, a poly surface, or a NURB surface, or a mesh. Okay, so you can machine a mesh or surface. For boundaries, you can, to contain your drawing, you can use curves. Okay, 4-axis is very similar. For the index 4-axis, that reverts to the requirements of either the 2 or 3 or hole making, whichever operations you do in a fixed orientation on that 4th axis. So for 4-axis fixed, you can revert to the requirements for hole making 2-axis or 3-axis. For simultaneous 4-axis operations, you do need a surface or a mesh to calculate those continuous 4-axis operations. In 5-axis, you need either a surface or a mesh similar to 4-axis. It's a little bit more to understand in 5-axis, because if you do continuous in the index 5-axis where you're rotating in planes, that will revert back to the requirements of whatever you put in that indexed fixed orientation. Drilling, 3-axis, revert back to those requirements. For 5-axis, if you're going to do continuous 5-axis or surface milling, you do need to have a surface, obviously, or you can do it with a mesh. If you're doing a continuous toolpath operation in 5-axis, you have 2 different types of geometry types. You have drive regions and check regions. So your drive regions needs to be a surface to calculate the normal direction of the spindles, because the spindle is going to orient itself in an orientation that's at right angles to any point on that drive surface. So that's what's going to orient the spindle for you. You can't do that with a mesh. You got to have a surface. You got to have preferably a NURB surface. And the check surface is just simply the mesh or the surface that you don't want the tool to violate. So that's pretty straightforward if you have a 3D surface model. If you only have a mesh model, then you need to add your drive surface. Typically, you can just put a cylinder inside your mesh, and you can use that cylinder to orient the spindle, and then it won't violate the mesh if you define it as a check surface. I'm not going to get into too much about the 5-axis. We have we actually have a case study coming up that's going to illustrate that, and we have plenty of webinars and blog posts to cover that. So we've got to get back to our drawing. We've got a 2D drawing, and we're going to be camming this drawing based on this cross section. So I'm going to be going a little bit slow. If you have any questions, go ahead and put them in the questions panel, and let's go ahead and get started here. So the first thing we're going to do, start from the left, work your way to the right, just like any new CAM job. Our machine is not going to change. It sets the 3-axis, whether they have 3-axis or 2.5-axis. So we don't need to do anything there. The post, I already have it set. We don't need to do anything there. For the setup, we're not going to do anything there because you have one set up by default when you create a new CAM project. So we're going to use that. And that orientation setup is on the XY plane. You can see the arrows here for X and the Y. And down here, you got a little toggle here where you can turn off the machining coordinate system. Okay. So by default, the machining coordinate system is aligned with the world origin. So we can just leave it off or on. It doesn't really matter. Okay. So for the stock, we are going to create some stock. You got to have stock to machine. Well, in 2-axis, you don't really have to have the stock, but if you're going to reference your depths based on the stock, you need to define your stock. So let's go ahead and we're going to just create a simple box stock. And I have dimensions already populated here. The stock that we're going to use is 23 inches by 20 inches by 3/4 or 3/8 of an inch, 3/8 of an inch thick. This is aluminum plate. And what this is basically is an instrument panel, a prototype of an instrument panel, and it's going to be just machined out of a 3/8 sheet of aluminum. Okay, so we're going to go ahead and pick OK. Now, there's one thing here that you might want to pay attention to, this checkbox for ignore wireframes. If you want to create your stock based on your drawing, you need to have this, we're going to have that unchecked. Okay, we'll pick OK. Let's turn the stock on. Okay, so we have our stock turned on. As you can see, it extends past the drawing. Okay, and here it is over here in our elevation view. Okay, now I have the stock a different color. Let's go talk about the CAM preferences right here real quick. We're not going to use that. Here's our stock. I have changed the stock color from the default color. I've changed it to a dark blue. Okay, our cut stock doesn't really matter because we're going to be using different colors for different operation types. For our edges, our silhouette edges and sharp edges, I have changed this to a lighter blue so you can see them real good on top of the darker stock. And I've got these two checkboxes checked to display these edges. Okay, cutting tools, I have those set to different colors. For machining, you might want to change this all the way to fine. This is really not going to come into play a whole lot because we're not doing any 3-axis. Down here, let's look at what else we got here. Okay, I've got my tool pass visibility thickness set to 2 so that they're a little bit brighter so I can see them a lot better. Simulation, we have it set to fine, transparency set, and that's really all we really need. Okay, so let's go in and start our first operation type. What we're going to do is we're going to be facing this 3/8 inch sheet. We're going to face it down to this first level top of the part. As you see, that level is at Z minus 0.0545. Okay, so let's go ahead and do a facing operation. We're going to go to 2-axis. We'll select our setup, go to 2-axis. We're going to do facing. Okay, for the geometry, that's going to determine the perimeter or the extents of your facing operation. We're going to do select curve edges, and we're going to pick this outer curve right here on the outside. Okay, for the tool, let's go ahead and save this because I'm going to load a tool real quick. Let's cancel out of there a second. I'm going to load a tool library. I have 2 libraries here. One is a tool library and the other is a knowledge base. They both have the same file extension. So if you do save a tool library or if you use the knowledge base, just make sure you describe it a little bit different unless you know that it's actually a tool library. So it's loaded 7 tools. Okay, let's go back into our facing operation. So we got our drive region selected. The tool, we're going to use a face mill. We're not going to mess with any feeds and speeds. Those are all relative to your machine or the type of cutting that you do. So we're not going to change anything. Here for the clearance plane, this is always going to be set to automatic, and we're going to transfer at the clearance plane. So here is the clearance plane if we zoom in right here. Okay. Okay, so let's go ahead and okay, there's one thing that I did not do. Let's go. Let me save this because I want to make sure we align this stock with our XY plane. And what we're going to be doing here is our drawing lies on the top of the stock. Okay, so you can see, maybe you see that drawing a little bit there at the top. So you can align the stock with the top. In other words, align it with the geometry on the top of the stock, the geometry on the bottom of the stock, whichever makes more sense to you for making sure you understand the cut depths. I have it set to the top because it seems to be a little bit easier for understanding your cut depth. So if this is the 0 is at the top, you know, it's pretty easy to understand how deep you're going. Okay, so I have it set to top for Z alignment, and I have it set to center in the X and the Y. Okay, so let's go back into our facing operation. So the tool, feeds and speeds, clearance plane, and the roughing operations, we're going to, the tolerance can be anything because we're using a large face mill. The tolerance in 2-axis only applies in the X and the Y direction. not necessarily to the depth, okay? So we're going to leave that set to 01. We're not going to leave any stock because we're cutting all the way off the edges of stock material. We're going to do an island offset cut pattern, a mixed cut direction. We actually can increase this a little bit for the offset because we're using a large cutter. Okay, for roughing and the cut levels. The cut levels tab on any of your 2-axis operations is probably the most important tab that you need to pay attention to. This area right here for your cut levels, this is what you're going to use to control your depths. In the drawing, you don't have any depths identified. So that's why I asked you to go ahead and create or sketch out on a piece of paper your elevation views. How deep are the different features that you need to cut? Okay, so this spacing operation, we're going to bring it down to the top of the part, which is at minus 0.0545. Okay, so what we're going to do here is we're going to enter the top location of our cut geometry. When we start, I placed it at the top of the stock. Okay, so we're going to leave the location of cut geometry to at top. At top, okay, is going to be the top of the stock, but it's also going to identify that the cut depths are going to be measured from the top of your geometry. Is going to be measured downward. That's why I said it's a little bit easier to understand if you have your geometry at the top of your stock and then you're machining downward. So we're going to go down right here. We want to go down 0.545. So we're just going to type in on the cut depth, total cut depth. We're going to go down 0.0545. So that's the bottom of our facing operation, okay? And we're only going to do it in one cut level. So everything we do is only going to be one cut level. If you need to do more, you can use these controls for the rough depth per cut, etc., to identify how many levels that you're going to cut. And we have plenty of other videos that goes over that as well. So all of our operations here, most of them are going to be just one cut level. So we have 0.545 for the total cut depth. It's going to be starting at the top and cutting down to 0.545. And let's just look at the, we don't have any entry and exit. We could do some lines and arcs since we're coming in from the outside to face this off. We don't need anything there. We're not going to use any optimization, just fix generate. Okay, so here is our facing operation. Okay, you'll see that it cuts down to 0.545 below our geometry. This is the top of the stock right here. Okay, and let's go ahead and simulate that. Any questions? Go ahead and put them in the questions panel. Okay, so we machined a facing operation, okay, to bring that stock down to our 0.545 level, which is the top of the part, okay? And we're going to be looking at this cross section as we go along. We can correlate it with our drawing up here to make sure that we're in the right depths. Okay, so that's our facing operation. Now let's go into a pocketing operation. We're going to go pocketing. Now this drawing or this part, this outer edge here is a pocket. Because you think of this instrument panel, this is going to be setting on a cabinet, and this pocket right here is going to be where the front edge of that cabinet is going to position itself. Okay, so this is actually a pocket coming from this curve to this inner curve. So let's go ahead. It automatically created one region from our last region. We're not going to use that. We're going to remove that. And then we're going to select two regions. We're going to select this inner edge here. So this is actually a lip, okay, on the outer edge of the part. And then we're going to select this inner region here. So this is going to be a pocket. Right click, we got our regions in there. For our tool, we're going to use the 1/4 inch flat end mill to get in here real good. And we're going to use, let's get to our cut parameters. Okay, we're going to increase this to 1,000. And also, in the pocketing, we're not going to use, we're going to do the pocketing so that we're going to do it so that it's a combination of both a roughing and a finishing. I'll show you how we can do that. So we're not going to do any separate profiling to finish these edges up. So we're going to do a tolerance of 1,000 since we're cutting right out to our edge geometry as a finished cut. And we're going to leave our stock set to 0. Okay, so we're going to finish it right out to the edge. We're going to use an offset cut pattern, so it's going to be offset around these curves. We're going to do a mixed cut direction. We're going to start cutting on the inside, so it's going to start cutting inside the pocket. And we're going to do an offset. We can increase that, say 45. One thing I do want to do here, if you're not going to do a finishing profile, go ahead and check this box for a cleanup pass, and that will add an extra pass to clean up any area. So it won't really apply much to this outer perimeter, but we do have this angle here, so there probably would be some extra stock in there as we do that pocket. So checking the cleanup pass will make sure you clean all that up on the inside. Okay, so let's go to the cut levels. Okay, so where's the top of our cut? Well, the top of this cut is going to start right here at the top of the part. That is not the top of the stock. We've already cut it down. Okay, so we don't want to use the at top. When you pick at top, that goes to the top of your stock, or at bottom goes to the bottom of your stock. We don't want to cut on either one of those, so we're going to use the pick top. Now, if you're camming from a 2D drawing, you're going to be using pick top a lot, so you need to understand what that means. So by pick top, you can use the arrow and actually pick a point on the drawing. It'll calculate that in the Z depth and use that as the top of your cut. We don't have that because all we have is a 2D drawing. So again, this illustrates the importance of understanding and looking at your little sketch here as to where the top of the cut starts. So for this cut, we're actually cutting, this looks like a counterbore, but it's not a counterbore. This is the actual pocket that goes around this on the perimeter, okay? And this through hole are these holes around the perimeter, okay? So the cut is going to start at the top of the stock, which is negative 0.545, okay? So we're going to type in negative 0.5, no, hold on, let me get that back again. Negative 0.0545. So that's the top we're going to start cutting from. In the cut depth for this here, you see, I believe it's 188.118. So we're going to put the cut depth of 0.118. Okay, so this is the importance of understanding when having a drawing on hand that you can refer to for your cut levels. So we're going to start similar to the facing. On the facing, we cut down to this level. On this pocketing, we're going to start at that level and cut down again another 0.118. Okay, so we're going to do that on one cut level. So your roughing is 118 and your rough depth of cut is 118. So it's only going to come up with one cut level. Let's see what else we got here. For the pocketing entry and exit, we're going to do a ramp. We're going to do a path. And you can see the little drawing here. It's going to be ramping down to the start of the pocket. And it's going to ramp down in the middle of the pocket. Okay. And we're going to do just a linear exit. Okay. So let's go ahead and look what else we got. Advanced cut parameters. We'll use some, we're going to add arcs to it. We don't really need arcs because there's no arcs on these curves, but it will make the cutting go faster if you have arcs in there. Sorting, we don't need that. We're not going to use that. Let's generate that. Okay, so we got a pocketing operation. Okay, and it used the outer perimeter and this inner perimeter, and you see this path right here. This is the cleanup pass, which goes all the way around the inner edge, which makes a good cleanup. This is actually a finishing operation right here, this cleanup pass. We got the stock set to 0, so it's going to cut right to the geometry on the outside. Let's go ahead and simulate that real quick. Speed that up. And let's look at this. Okay, so we got another cut level right here, okay, which is 0.118 deep, which is this cut level right here, okay? So this is the pocket, this is the base of the pocket, okay? So that's what we've done. Okay, so the next operation type, we're going to do a profiling. Now, in this part, let's go back to the program tab. We're going to go to profiling. Okay. On this part, we're going to profile the outer edge. So we're going to cut it out of the stock completely. And this part actually does have a number of holes in it. So these areas in here are actually pockets that cut all the way through the part. Okay. So you got pockets all over this panel. Okay. So let's remove all of our geometry. And for the geometry, we want to pick the select curve edge regions. We're going to pick the outer edge. Okay, so we're going to profile on the outside of that edge. We're also going to profile all of these because these cut all the way through the part. We're going to select that one. We're going to select this one. So we have two curve regions on this drawing. We got an inner pocket and an outer edge. So we're going to use the pocket. We're going to use this pocket, this pocket, this pocket. And there's another pocket down here. That's not the one I want. If you want to get rid of one, just press the control key and pick it again. It'll get rid of it. Okay, so what I wanted to pick was this outer one. Okay. Oh, no, actually I was right the first time. Let me get rid of that. Okay. Control key will unselect, so you don't have to reselect everything you picked. So these inner squares are actually the cutouts. I'm going to select those. And then these down here are cutouts. So these are going to cut all the way from the top of our part that we already have machined down all the way down to the bottom. Okay, I'm just going to right click there. So there is our regions that we're going to use to contain the profiling operation. For the tool, we're going to use the 1/2 inch flat mill. Feeds and speeds, clearance, we're not going to talk about that. Cut parameters, we're going to use a tolerance of 1/1000. We're not going to leave any stock. Okay, and for this profiling operation, we're going to do it in a roughing and a finishing at the same operation, and I'll show you how to do that. And we're going to do a mixed cut direction. We're going to use the midpoint of the largest side for the profiling, which is fine. We're also going to do specify the cutting side. We're going to do the right side, which happens to be the outside, okay? Or you can use the inside outside. We'll just leave it set to that. And then we're going to use this checkbox for alternate using nesting. And the reason we're going to do that is that the pockets or the profiles that we want to cut, they're nested. So you have one profile on the outside, you got other profiles on the inside. So it's going to figure out which side to cut automatically. So down here we have the stepper overs where we're going to tell it to do a roughing pass and a finishing pass. So you can give it a total cut width, and then you can do a step per cut. So the step per cut is in the X and the Y. So we're going to put this to 0.1, and we're going to leave that to 0.1 also. So it's going to break that profile up into 2 passes. Okay, so let's look at our cut levels. Again, a very important, or the most important tab on your 2-axis will be the cut levels tab. Okay, so again, where do we want to start the cut? Well, we have the part already machined down, okay, to this 0545. So obviously, if we want to machine from there all the way down, this pick top option needs to be the 0.0545, 0.0545. That's where the cut's going to start. okay? And then for the total cut depth, let's see if we got it on here, our total cut depth. Okay, we don't have it dimensioned, but you can refer to it by just adding two of these dimensions. Like we're going to add the 118, okay? Or take the 3/8 and subtract the 118, okay? And that comes out to 3205. So we're going to do 0.3205. That's going to be the total cut depth of the profiling operation, and it's going to go all the way down to the bottom of the stock, okay? And let's go ahead and let's do this at a couple of cut levels, since we are cutting, almost 3/8 of an inch. Entry and exit, we can go ahead and use a ramp entry, do a long path, and we'll just retract straight up. Okay, let's go ahead and generate that. Okay, so we've got a profiling operation. We've got two passes. The outer pass, you can consider that as a roughing pass. The inner pass with the stock set to 0, that means it'll be a finish pass right on the curve. Okay, the same with on the inside. It automatically calculated this was the outside, this is the inside. Okay, and it automatically figured out the side to cut. So it's going to have two passes, one roughing and one finishing for all of these holes. And here we got arc motions here. Okay, and then if you look at our elevation view, we're cutting down. This is the top of the stock. Remember, this is our drawing. Okay, even though that's where our geometry is that we selected, that's not the top of the cut, but because we defined the top to be cut levels, where are you? We defined the top of the cut to be at minus 0545. That should be a minus. Okay, regenerate that. Okay, this looks a little bit better. So here's the top of the stock. That's where our drawing is. We've already cut down 0118. So we're going to go down further 3 cut levels to get to the bottom. Okay, so let's go ahead and simulate that. Okay. So what we've done here is we've actually profiled the outer edge, okay? And these there's some inner edges here, okay? Let's go ahead and look at this. Okay.
Just a quick note there, Don, on the cut levels. Some people get confused that the cut depth is actually absolute value, but in our system, the cut depth is actually the coordinate value. So with respect to your 0. So that's why Don had to specify a negative value, which means you're cutting below the 0.
Right.
So that's an important distinction that we have to make.
This point that we want to start cutting is below where our setup coordinate is, which is at the top of the stock. If you remember, we created actually we didn't create a work 0. You don't have to have a work 0, but by default it's at the top of your stock. And we entered a negative number, which brought it down to this point right here. Okay, and then our cut depths went from this level on down. We used 3 cut levels. Okay, so we have, let's turn this off. So for our drawing, just to go over real quick, we faced it off down to the top of the part. We did a pocket, which is this area right here. You can see it a little bit. This is the pocket on the outer edge. And then we did some through holes, which go all the way through. This is some of the edges here. I know it looks a little complicated, but you probably get the idea if you look at this profile, this section view here. Okay, so let's go back over here. And another thing I want to show you is that when we simulate this, let's play this again. I want to go into my preferences and I want to do the simulation. I want to do it from semi-transparent for now. I'm going to do it opaque so we can see the stock a lot better. Okay, and let's just go up here. Now, what I've done is, if you recall, I made the stock color a dark blue, if you remember, and I'm going to go in here and I'm just going to change some of these colors you can use the properties option and you can change these colors, and I'm going to change the colors for my facing. Okay, and I'm going to change the color of this pocket, and I think I used that. Click OK, and then this one is going to be the same. Okay, and to get these colors to show up, use this little drop down here. So the default for the properties is going to be to the MOP, meaning MOP is short for machining operation. So I'm going to pick MOP, and you'll see that the colors now appear in the simulation. So it just makes it easier. We highlighted these edges in white, as you can see, or very light blue. So you can see the edges real good. You can see where the profile cuts go, and you can see where the top of our pot is down here. Okay, and then also out here. Okay. Again, if you got any questions, I know this is a complicated part, but I'm trying to go slow enough you can get the idea of the cut levels. Okay.
Don, there was a question about the cut levels. When you get some time, can you walk through the cut levels again?
Yeah, we're going to be doing it for a number more operations here. Okay, so let's go. The next one we got is another profiling operation. Okay, and what we're going to go do here, let's go back over here, 2-axis profiling. Now in this profiling operation, you'll see that we have another level right here. If you look right here, this is another level. This is this level right here inside these areas right here. So we got holes which are tapped holes here. This is the tapped hole that represents that cut level. So we actually have, I guess you could consider them pockets, but it's just only a pocket when it comes out to here, because you don't want to pocket all of this out. You've already cut the inner hole out. So we're going to use a profiling, and we're going to give it an offset so that it cuts offset just enough to get out past this edge right here. Okay, so we got our geometry. Let's see what we're going to select for geometry. We're going to remove this, and we're going to pick these outer edges here, and we're going to pick these outer ones here. So all of these curves right here, this is a pocket. Okay, this is this cut level right here. It's going down from 0545, it is going down 0.118. Okay, very similar or nearly exactly the same as this pocket on the outside. The depths are exactly the same. Okay, but we're, instead of using a pocket, we're using a profile. So let's go ahead and right click. So let's select the tool. We're going to use the 0.5. Feeds and speeds, clearance, cup parameters. Again, on the cup parameters, we're going to leave it at 1,000th. We're going to leave the stock to 0 since we're finishing up on the all the way around here. And for the cut direction, we're going to leave it to mixed. We're going to start at the midpoint of the curves for the start cut point. And again, we're going to use for the inside outside, we just go ahead and use this option. We're going to cut on the inside. Okay. Now here is where we're going to use it to, again, calculate a roughing and a finishing. So we're going to use our roughing. So we're going to give it a width. This is going to be 0.3 this time. And we're going to use an offset of 0.15. So what's going to happen here is it's going to back off from the perimeter 0.3, which is further enough away to get past this hole. Okay, so it's going to be like a little shelf right here. Okay, so let's look at what else we got on our cut levels. Again, let's look at our section view. This area what we're cutting, okay, is a profiling operation, and it's cutting along this edge right here. Okay, you see this edge? And this edge, and it extends out past this edge. This is that edge, outer edge, inner edge right here. And these holes are the drill and tapped holes right here. Okay, so the section view only does one side of it. You don't see all of it, okay? So the start of the cut, again, is going to be at the negative 0.545 because we already have it machined down to that cut level. We're going to start there and want to come down another 0.118. Okay, so let's enter. We're going to use the pick top again. Just like the pocketing, we're going to enter negative 0.0545. Okay, that's going to tell it that it's going to start cutting right here. Okay, and we're going to cut down 0.118, just like the pocketing. We're going to do it in one cut level. Okay, so again, if you want a little bit more understanding, you can look at this picture right here. Okay, so we're using the pick top. Okay, the top of the cut, we're saying that it's negative 0.0545. It's not at the top of the stock. It's not at the bottom of the stock. It's at this cut level right here. Okay, so that's in this picture right here. That's illustrated by the orange line right there. Okay, and then the blue lines are the separate cut levels. Okay, you have a total cut depth of 0.0545. If you look at this total cut depth picture right here, this comes from the top of the cut all the way down to the bottom. Okay, actually in this cut it's not going all the way down to the bottom. It's only going down 0.118. But this illustrates the different cut levels. You can use this field right here to tell it how many cut levels. You can use the slider, or you can tell it exactly how many cut levels you want or how deep they go for each cut level. We're just using the same value for the total cut depth because we're only using one cut level. If you wanted to use multiple cut levels, you can just enter the actual value. It's a positive number. The actual value of each of the cut levels. How many times does a tool cut to get down to the bottom of your profile? Okay, so we're going to use just one cut level, and we're not dividing it up into roughing and finishing. We're just doing one cut at the bottom of the profiling operation. I hope that makes that a little bit clear. We're going to be talking about this a little bit more. We got another 2 operations to do. So entry and exit, we don't want to use arcs and circles because we're constrained inside this area. We're going to do a long path to do a ramp in, and we're going to do none to do a retract straight out. Okay, so let's look what else we got here. We're using the 1/2-inch tool. We've got arcs. We don't really need any of this because we're doing an inside cut. We're not going to do any of that. We're not going to use that. Let's generate this. Turn that on. Okay, so you'll see what happened is it created 3 not cut levels, but 3 step overs. Okay, so the first step level cleared it past this cutout right here, and then the last one is the finishing path. Now you might be asking, well, you're cutting air right here, because this already goes all the way through. I'm not going to worry about that. The way we did it right here is the fastest and the easiest way to understand how to do it. If that concerns you, you can go in and just, create like a square box around that area if you want to do it that way on both sides. It's up to you. But we're just doing this, perimeter on the outside. And it's the same over here, and it's the same here. The offset, X and Y offset, is enough to clear it past these circles. Let's go ahead and simulate that. Okay. Let's change that color to, say, green. Okay. And let's look at our profile here. So we have another, I need to change this stock to some semi-transparent. Okay, so this cut level is at the same level as the pocket. You'll see that, it starts over here and it cuts this profile goes along at the 0.118 depth, okay? And that is at this cut level right here, level C on the drawing. And if you want to, we can simulate that a little bit slower. Okay, so that it cuts out, let's turn the toolpath off. So it cuts out, let's turn this back to opaque. So it cuts out past this through hole. So we get that lip that we need to do these tapped holes on. And it does the same thing on the other side. Actually, I didn't select these two either. So let's go back in here. We're going to pick the shift key down and we're going to pick these additional ones. So it adds it to them. Let's regenerate that. Okay, so we got the 4 cutout profiles and these 4 or 5 through holes there. Let's simulate that again real quick. Okay, so there's our part as it is right now. Now, what do we need to do next? We get about 10 minutes, so we're going to go a little bit faster in here. So we're going to do another profiling operation. Okay, let's do another profiling operation. Let's get rid of that. And for this one, there's another ledge right here. Okay, so this is the one we're going to use, the outer one. And again, you'll be cutting some air. I'm not going to worry about that. So we're going to use that for the cut level. The tool is going to be the same. Everything's going to be the same. That should be here. I need to do that to, I believe, let's see what it needs to be. Okay, this time is 0.2. And it's going to be a 0.1 for the step over. Okay, for the cut levels. And where are we going to start at? Very similar. We're starting at the top of our facing operation, and we're cutting down to this level right here, just like the pocket and just like these shelves right here. So we're going to do this. The pick top is going to be negative 0.0545. The total cut depth, again, is going to be 0.118. Okay, so we're going to make one cut level, 0.118. And entry and exit, we'll do a ramp, and we'll do it extract straight up. And I believe that is it. Let's generate that. Okay, so let's look at the tool. We need to use a smaller tool. Okay, so we look at the top. You'll see that it's doing a profiling operation. The stock allowance is 0, so it's cleaning out. It's like a finishing pass on the inside. So it's starting 0.2 away, and it's working its way in to do a finishing pass around it. And again, this is cutting air, I know, but it's the easiest and most expeditious way to program it. So let's go ahead and simulate that real quick. Let's change this color real quick. Change that to green. Okay. Okay. So there's our shelf right there. Okay, so let's go to the top. And now we're going to do our drilling and got some tapping. So we're going to go up here. We're going to go to hole making. We're going to do drilling. And as I mentioned, I have all of those holes selected as predefined regions, and you can select those by using this select predefined. So for these holes, it's going to be, hold on just one second. It's going to be this first set here, the outer holes we're doing. So we're going to pick OK. So there's our hole selected. And for our drill, we're going to use the 1/4-inch drill. Okay. And for the cut parameters, we're going to go since we're cutting relatively deep, we're going to do a deep drill. Okay, so now in drilling, you know, this part is only 3/8 of an inch, less than 3/8 of an inch. I'm not going to be too worried about where the drill starts turning on at, because that's, you know, where your cut top is. So I'm just going to say that it's at, you know, you can say the pick top, say, is at the top. I'm going to leave it at the top. There's some air up there, but it doesn't really matter, okay, for drilling. Okay, so I'm going to leave that at top. Okay, for the total cut depth, though, we want to make sure it goes all the way to the bottom. So we're going to, for the cut depth, we're going to enter 375. Okay, so it's going to go from the top of the stock down to the bottom of the stock for these through holes. Now, to make sure it goes all the way through, we're going to pick this checkbox with add toe tip to the drill depth, and we're going to leave all these parameters to the defaults. We're going to increment. We're going to do like a peck drill by 0.1 increments. We do want to do some sorting. Let's generate that real quick. Okay, so here, let's turn that on. So we have our drilling operations. Simulate that real quick. Let's change the color. Change that to green. Okay, so here are our through holes. So you can get a good look at that. Okay, so there's our through holes. Let's look at our cross section. Again, I got to change the stock so we can see through it. Okay, so there's our hole. And if you look at our drawing, there's the hole that we're talking about. Okay, so this is the pocket that goes all the way around, and this is the through hole. Okay, let's move on past. We got a couple more drill operations to do. So we're going to do another drill operation. This time we're going to be selecting this predefined. We're going to select these holes right here. These are actually, these are tapped holes. So we're going to be doing the tap drill first, and then we're going to be doing the tap. So we're going to pick OK there. So we got all these holes selected. This is why it makes it a lot easier if you do predefined regions. You can select your regions ahead of time, and it makes it real easy to select them. So for the tool, on this tool, we're going to do, and if you're wondering, I've got another drawing on my other screen here that's already done. So we're going to use the tool. We're going to use the tap drill. Okay. For the feeds and speeds, clearance, cut parameters, we're going to do a deep drill again, and we're going to do for this one, we're going to tell it where to start cutting. Okay, you don't need to. You can leave it the same way before, but I'm going to do it both ways. So for this particular cut, it's at this second level here. It's at this level. This is the facing, this is the pocketing or the profiling. Okay, so that depth where it starts cutting at is to be calculated at a pick top of negative 0.173. That's what that depth comes out to be if you add those dimensions together. So that's going to be where it starts cutting, okay? And the cut depth is going to be 0.15. That's the remainder, that's the cut depth from here down to the bottom of the hole, the tap drill hole, okay? So that's going to be 1.5. Let's see what else we got. We'll leave the increments of 0.1. Sorting, we do want to have sorting, so we're going to do minimum distance. Okay, let's go ahead and simulate that real quick. And let's go ahead and change our preferences. Okay, so here are these tap drill holes. Change that color. Okay, yeah, since that's green already, we can change it to a different color. Let's make it purple. I like purple. Okay, so these holes, if you look over here, this is all of these holes are all tapped holes. But if you look over here, we got to change our stock back to transparent. Okay, so these are the tap drill holes for the tapping. Okay, and what's good about having your drawing, obviously, right there on the screen, is you can verify, that you're cutting to the correct cut level. Okay. Okay, so let's go and go back. Let's go ahead and go to the top view, and let's turn our stock off for a moment. Okay, so let's go ahead and do one more drilling. We're going to do these holes right here are drilled all the way through, just like these are, but I believe they're a different diameter. So let's go over here. We're going to do drilling, and we're going to use the cut level. I mean, for this geometry, predefined, it's this third set. So these are all through holes. We're going to pick OK. For the tool, we're going to use the 3/16 inch drill. That's why I didn't do them with this one, because these are 1/4 inch. These are 3/16. Beads and speeds, clearance, cut parameters. We're going to do a break chip. So that's actually going to be, it's going to be pecking down. It's going to be breaking those chips out of that hole as it goes down. So again, I'm just going to let it go from the top of the stock on down. So we're just going to let that be at top. We're going to set this to 375, which is the thickness of the stock. Okay. And we're going to leave that the same. And for sorting, we'll do a minimum distance. And let's go ahead and check one thing. I want to make sure this is checked because it's a through hole. Let's generate that. And let's go ahead and simulate that. Okay. So we got, it's kind of hard to see, but we have a through hole. The through hole actually isn't shown on here. I guess no. It's similar to this at this level, but it's a smaller diameter hole. You can see some of them right here. These are those through holes right here. Okay. So let's go back over here. Now we're going to do the tapping. Again, if there's any questions, go ahead and put them in the panel. So let's do holes. We're going to go tap. We're going to use the same set of holes. No, I'm sorry. It's this set of holes. These are all tapped holes. Let's pick OK there. It adds all the holes. The tool is going to be a tap tool. And if you want to look at that, this is set up for a 1024 tap. And cut parameters. Let's go back over here and cut parameters. We're going to use a PEC tap, which is similar to a PEC drill, because it's going to tap a little bit and come back out and tap a little bit more to make it a little bit easier on your tap tool. And we're going to do at top. Okay. Tap depth is calculated to be 323. So we're going to use a depth 0.323. That's, if you calculate that, it's this level right here. Okay, so we're tapping to the bottom of this hole. Okay, and it's going to be a right-hand thread. Sorting, obviously we need some sorting. So here is our tap drill. Let's go ahead and simulate that. Okay. Let's see where that is. Okay. Okay, it looks like it went a little bit too deep. Let's go ahead and back over here. Cut parameters, total depth. I'm backing up and looking at the depth of the other one here. Cut parameters. Okay. So this actually is 0.15. And we're doing a pick top. 0.1 negative 0.173. Okay, that should get it. Okay, there we go. So it's tapping down to the bottom of that hole. You don't see the drill tip though in there, but that's what the tap does. So that's basically, we're at the end of it. So that's our drawing. Let's go back over here and change that to opaque. And let's look at our drawing here. Let's turn the stock off. Okay. So that is all of it. We got the facing, we got pocketing, we got profiling, more profiling, more profiling, drilling. That's a deep drill, a brake chip drill, and then a tap. Okay. So let's go ahead, and we're a little bit over, so let's go ahead and post this real quick. I have the post set up to a Haas with cutter comp. We're not using the cutter comp in this though, but we're just going to post it. So here is our tool, our G-code file. Okay. As you see, we got all kinds of drilling. We got tapping in there. We got all kinds of coordinates for profiling and facing. And there we go. Any questions, Joe, before we wrap it up?
Yeah, we have a few, but since we're out of time, we'll have to handle some of these in our next webinar. So
okay.
Some of those were related to helix cut patterns, machining regions, quite a bit of in-depth topics that we'll add to other webinars, upcoming webinars. So
okay.
There were a few that were answered already. And so thank you, everybody. Hopefully you were able to get some good information out of this. As mentioned before, we'll be sending out the video, and I also sent out the blog, a link to that blog article. So together with the video and the blog, you should be able to make a lot of sense out of what Don was showing. It was a quite complicated part, so it might need a little bit of research from your end. So
and again,
hoping to see you next month.
Yeah, go ahead, Joe. Sorry.
No. So go ahead, finish up, Don.
Yeah, I was just going to say, if you got any questions, just drop us an email at support@MecSoft.com. Sorry, I interrupted you, Joe. Go ahead.
Yeah. All right. Thank you all, and see you next month.
Okay.
Bye-bye.
Take care, everyone. Bye-bye.